Once again, I'm your host, Alex Debrie. Happy to be back with you again this week. We're going to be continuing our internals of Redpanda series. So, our last episode we talked about tiered storage, shadow indexing, and some of the optimizations that Redpanda's done on the read path to make, tiered storage work really well. That's where you're storing data in S3, some older historical data, but sometimes you want to read that back out. What are the optimizations Redpanda's done on the read path to make that really efficient for you and not really notice that latency from the client? So that was the read path last week. This week, we're going to go into looking at the write path, right? What are the optimizations that Redpanda is doing on the write path to offload that data to S3 or other blob storage as it sort of ages out? And to do that, I'm going to bring on, my guest, the other Alex G, co-founder of Redpanda, knows more about this space than just about anyone. So Alex G, welcome back again to Real Time with Redpanda.
Thanks for hosting, Alex. It's always fun to be here. Yeah, so today we're going to talk about the tiered storage write path. And I always felt that actually for those in the audience, if you missed something last week, the thing about tiered storage is just really how many levels of the onion we're going to peel in any one particular. It just goes so deep, all the way to really the back pressure from the device. So if you, for people that are on YouTube or Twitch, if you want to ask more questions, if you wanted to come back and revisit and explore a particular area, just let us know. There's really, we just have an iPad and we're just going to talk about tech. It's usually a ton of fun. There's no real structure to this thing. So I just wanted to bring it up there because I know a couple of people DM me and they were like, hey, we should maybe talk a little deeper about other stuff. So yeah. And today we're going to talk about the write path.
Awesome. Excited to get into that. Before we do, I did want to talk about a few other events that's going on. It's a really busy week for Redpanda. So actually 2 different sort of talks and events going on tomorrow. Number one, James is going to be giving a webinar for the Linux Foundation talking about data transforms with WASM. Really good blog post on the Redpanda blog last week about WASM, the WASM engine, and some of the problems that solves, with Redpanda with streaming data. So go check that out. Also, there's a talk tomorrow at Scilla Summit. So this is the folks at ScyllaDB. And we have Dennis from Redpanda. He's going to be talking about some of the performance optimizations around streaming transactions and the work that Redpanda's done there. So I'm going to post some stuff in the chat if you want to go check that out. Make sure you find those. But other than that, Alex, let's go ahead and get started with some of the write path stuff here. And first, before go ahead. One thing I want to say is just set this in context for us. Like, what is tiered storage doing for us? What is shadow indexing doing for us before we get into some of those optimizations?
Totally. Actually, one quick comment on the 2 events that you mentioned. I think why people might be interested in that. WASM solves the problem of ping pong in data. So often when you have Redpanda and let's say a Kafka Streams application, let's say to just remove the social security number, you end up ping ponging your data back and forth between the 2 systems, and network becomes the new bottleneck. And so you kind of keep shifting the bottlenecks around in computing. And what WASM gives people is the ability to do this inline processing. So still in technical preview, we want your feedback. So if people are checking it out, the API is mostly stable. I think that we feel good committing about that kind of API. So it's going to feel very similar, but definitely if you try it out, we're planning on maturing this thing, and it's going to be a very similar for the inline and asynchronous. Check out the blog post for that. I just wanted to highlight that. And then transactions, I am super proud of the work that Dennis has been doing for context. His first job, his first like big engineering task at Yandex when he was in Russia, 10 years ago, was to add transactions to Apache Kafka. And he wrote this blog post on why 10 years ago it was too hard for him. And so he spent the last 10 years really becoming an expert in consensus, in transactions, in protocol, in correctness semantics. And then a decade later, the stars aligned for us and for him. He had just left Dropbox. He was on this sabbatical. And we ended up chatting. We connected over Twitter, out of all places. He came here and was able to actually implement transactions on top of a new storage engine, so Redpanda. And so it's a lot of fun to see him evolve and being able to now deliver the performance of transactions. I won't spill the talk, but it's super fun. He's done some incredible optimizations on that, and he's really a world expert in when it comes to transactions and correctness. So both are really fun to check out, and I'm sure there's going to be recording, but it's always more fun to attend the live streams, and then you get to ask questions to the author. Anyways, with that, we should switch back into tiered storage. I just wanted to give people a little more context because they're just too cool to just mention them briefly.
I love it. I love especially that transaction stuff, and just, some serious world-class experts at Redpanda. Your experience with streaming, his with transactions. That's why you see the performance gains we're seeing. So I love that. I'll turn on your iPad here if you want to start sharing some stuff, Alex, and get us into tier storage here.
Yeah, right on. There's a Swag code called #RightPath that we'll talk about at the end. So yeah, let's talk about the motivating example of really tiered storage. I think that last time we just kind of went deep into just into tech, which is fine. It's always fun. I think I failed to mention a couple of really strong motivating examples in drawings. And by the way, this time, for those of you tuning in, we're using new software to draw. So if you see glitches, please let us know on the YouTube stream. We've tested this, but let us know. So when Redpanda really first started out, we had 3 nodes of Redpanda. And so let me give these IDs. Let's say 1, 2, 3. And they really communicate with each other. Let's just say 3-node cluster. And so we had a customer that said, "Hey, can you store a terabyte of data on these 3 nodes and give us a quote, right?" And so we said, "Okay, sure." To store 1 terabyte of data, replicate it 3 ways. So let's say replication factor is 3. That means that we're going to install a 1 terabyte hard drive on all of the computers. And usually on clouds, you use RAID 0, right? So we recommend running on XFS and then running on RAID 0 to stripe this. So this is really a technical side note. But the point is that if you have a client, right, and so that is writing to Redpanda, and the data retention, right? So you want to size your cluster in the same way that you size the database, like how much data are you actually going to store before you do some sort of compaction. And so we started with 1 terabyte, and so we gave this customer a quote. And then we said, "Hey, by the way, we are working on removing that limitation. And the idea here is that in the cloud, right? There's this thing, S3, and we have GCS and Azure Blob Service, I think it's called. Long story short is that what we really want to do is that as soon as data ages out here, we kind of upload it onto S3, right? Like that's the gist. And we talked about last time how really these are segment files, and they're typically, let's say, 1 gigabyte. Kind of going too deep here for a second, but the point is that
and when you say ages out there, you mean like sort of it's not accepting writes anymore to that particular segment, but also like most consumers probably aren't reading for that anymore. It's most consumers are near the tail log and
exactly. Most consumers are tailing the log, and this is really for all data, right? So this would be a terabyte minus 1 gigabyte is the first one that gets uploaded to S3. So when we share this idea, it's like, oh, by the way, we can upload it, and then if you needed it, what happens is we'll rehydrate this back onto the machine on a little bit of a scratched disk space, and this is where our cloud really comes in and shines, in that we can provision multiple different devices. Let's say the local device for that physical computer is local NVMe SSD, so super fast for caching. We may decide to for the tailing writes, we may decide to write it to let's say an EBS volume. So okay, long story is that then you can rehydrate it, and for them it meant that just in terms of cost on hardware infrastructure, is that the cost of let's say the cost of the cloud storage. So once we said, oh, we could do this technology, they said, okay, go from 1 terabyte to 12 petabytes of data. And so what's interesting is that, let's say that in terms of computing costs, this was 50,000. You move from that to $1.2 million. And why is this useful? This is useful because if you look at the cost structure, the computing is really lost in the noise, right? Like now the computers, what matters is that your cluster is a scaling factor of the actual data. This is a really good kind of cost-efficient infrastructure, right? It means that you're paying for the right things. Like data is the important thing, and what Redpanda is allowing you to do is just transparently tier this data. But this is a really strong motivating example. And for them, it meant, I'll just throw a couple of things, and then we're going to get more technical in a second. I'm just motivating the example. It means compliance, and now they have a mean time to recovery, basically RTO, and so how long does it take to recover? But what's cool is that on the technical side, let's say that we crash this node. It allows us to bring up a new node. Let's say a new node here, ghost node, in its place, and simply point the new node to this node's historical archival point, and Raft would experience no correctness loss, right? Because the only thing that you're doing is, so think of this in a file perspective. What you're saying is that you had, right? So imagine that you have a file, right? So a file on disk, and you write in data. What we did is we wrote a smart pointer to the file, right? And we called this a handle. And now the handle can be virtual. And so you can point the handle at S3, you can point a handle at, let's say, an NVMe, and then you can point a handle, whatever, at an EBS volume. But from the point of view of the storage engine that is on this side, it simply sees a file handle. And the handle has all the intelligence to kind of communicate with other subsystems, for example, like the caching layer and so on, object materialization, and so on. But this is why, let me go back real quick to the second slide, because this is the motivating example, and I realize we're already going too deep. So the point of it is that this tiered storage really gives us, it allows companies really to scale for that. And then the second motivating thing here is that it unifies real-time and historical data. And so if you're, and by that, let's be specific, because I think that there's a lot of claims for people that do this, and there's a lot of mental models, and people refer to that, oh, are you unifying real-time and historical data with the compute model, or are you unifying that with like Flink or with that? What I mean by that is specifically, it's you can use the same Kafka API client, right? So let's motivate the example. Let's say that you had, let's go here. Oops. Is this it? Yeah. You had a fraud detection, which is what we talked about last time. And in that computer that we talked about, let's say you have 1 terabyte. Let's say that your fraud detection now needs to consume, let's say, 2 petabytes. And so what it's going to do is it's going to first, so the broker, right? So the client has no idea who it's talking to. The client still talks to Redpanda. And so it asks this, and Redpanda has reserved a little bit of a scratch space to download and communicate with the tiered storage, the first 12 petabytes, and then it's going to automatically switch transparent to the client where data is coming from, whether it's coming from this scratch disk space or it's coming from this tailing iterators. You can simply tell the client, oh, by the way, just start consuming from, so say from 5 years ago. And your code doesn't change. So when we say unifying real-time and historical data, this is actually specifically what we talked about. Does this make sense as a motivating example? Maybe I went too deep too quickly.
No, I love it. And just like to put it in my own terms, you had this client come to you. They happen to have 12 petabytes of data, but they're like, hey, that's infeasible to store in Redpanda and accessible. So we only want to, what would it take for Redpanda to handle 1 terabyte of our data? But as you work with them, it becomes clear to them, hey, you can actually store all 12 petabytes, access it via the Kafka API through Redpanda, but still get the cheaper storage costs, rather than having like this two-tiered system where like, hey, some old historical data is in S3 or GCS, not behind the Redpanda API. Now, if you want to reprocess that, you need to write your own system that processes that first. Once you're caught up, then you switch over to Redpanda or whatever.
Is exactly right. And I think fundamentally, what happens is people have two pipelines. And so typically you have like your real-time pipeline, and then you have, let's say 3 brokers. And this is not a panacea. Like, I understand people often need materialized views of this, and we'll talk about this in a second. They have your real time, and then you have your regular, Kafka clients and servers, right? Excuse me, consumers and consumers, and then you have your producers. And then alternatively, what happens is, in addition to, what happens is that as data ages, they manually have a thing called often S3CMD, which is this program you can download, or like you can use the AWS CLI, whatever, etc. And they manually, there's a cron job that uploads data onto tiered storage. And then the fundamental issue here, and then there's this is a dark thing, like nobody really knows how that works. But then they have a separate set of, right? So like you have one code base, and then you have a separate code base for let's say historical data.
Yeah.
And so that having this secondary path is, I mean, it's fine. People have done it, and it's just, but it's more complicated.
It's in sync and doing the right thing. Yeah, it's complex. Now you have to know 2 systems, all that stuff. Absolutely.
Yeah, and often people actually end up storing 9 times their replication factor, because the problem here is that the storage is the storage engine itself, in particular the controller, our Oracle, is the only process in the world that actually understands the correctness of the data. And this kind of starts to bring us into the first benefit of our sort of tiered storage implementation, is that let's say when you have these 3 computers, and let's just do one for simplicity, and then you have a cron job that, let's say, runs every minute, right? So I don't know, is it *1, something like that? I kind of forgot the cron syntax, but the one is it runs every minute, and then it runs some like backup sh, right? And so you put it in the root directory or whatever you want to put in, or usually if you're a big enough company, like Akamai has a thing called A, and so you put it in a directory structure that you can find it, and then you run this script. And then what happens is that the logic is not centralized. And so you do this work 3 times, right? Or actually n times, because you have to do that per computer. And so what happens is that instead of actually uploading 1 terabyte to S3, you end up doing this 3 times. And then the recovery process is manual, and people have automated this, and this is really how this works. But you need the correctness of the data of this engine itself to remove these additional replicas, these additional copies in S3. And the controller is the only piece of software in the world that can give that correctness. And so actually, as a function of data storage, to me, this kind of intelligence only belongs in the storage engine itself, because otherwise then you end up, and then at some point right now, imagine if we go back to the motivating example, you go from $1.2 million spent a year to now $3.6 million. So it's materially different, and it often, this is, I think, the main problem for a ton of companies, is the reason they haven't unified the real-time and historical data is impossibly costly. It's just it's too expensive, right? So in order to do 12 petabytes on machines, what people do, and they do this to this day, by the way, this is like both solutions are done today. They take, they over provision their Kafka cluster, and they reason to themselves. I think humans are really good at like, what is it called? It's just like reasoning into your decision. In Africa, what is it called?
Motivated
like
reasoning or something
yeah,
like that.
exactly.
Or
Where you
maybe
just
it's a different
convince yourself of your own
Yeah.
BS, really. It's like,
Yeah.
oh,
Yeah.
it's like when I buy
Been
whatever
there.
new piece of audio equipment. Is the audio equipment, it's not me. It's the same thing with this, where to people have made these technical decisions where they over provision the Kafka cluster to be able to reason about historical data, as opposed to implementing this. And then when they implement it on their own, at some point it starts to become too costly. I think when you start to get into the petabyte scale, or the tens of petabytes, this is when it literally breaks the bank. And we meet with some customers where they say, Kafka is really the biggest cost center for us. And so that, anyways, does that motivate the example?
Yeah, absolutely. And I mean, just look at the numbers there. You talked about moving from 1 terabyte to 12 petabytes and how that increased the cost, 20x, but you're also increasing the amount of data, 10,000x. So,
Exactly.
if you wanted to store that on machines, that 50K is going to turn into, you're just not going to be able to store that in a reasonable way for most people. And mostly that data is sitting idle, right? Because most of your consumers aren't reading it. Every once in a while, you need to reprocess the whole historical stream, and that's useful. But on a day-to-day basis, you don't need that sort of sitting live, ready to go from your Kafka
Totally.
brokers.
And if you look at it, I've been part of some bigger companies where you have to store all of the data for like 5 or 7 years.
Yeah.
And I worked at some financing companies, and so I asked the compliance department, well, actually, how many times has the government ask you for this data, or like the health department? And in like the course of 7 years is like twice. And so it's like paying whatever $50 million or whatever it is to really like read the data twice. It's just such an exorbitant amount of spend. Like, $50 million basically gets you a team of probably I don't know, let's say 150 engineers, 100 engineers or so, maybe 150 engineers. So anyways, and then this is really kind of starts to change the reason of how people are using streaming today, or really how people should start to think about streaming, which is, if you can store data cost effectively, if you can deduplicate the number of copies, so that to the application it appears as one, even though S3 has its own replication, right? From the point of view of the application, there's exactly one backup on S3. And there is correctness around data deletion. And so one of the optimizations that the storage engine is the second thing, the only thing that can guarantee this, is that assume that we have topic partitions. And last time we introduced the idea of a topic partition, so a topic is a named collection. And so let's say clicks. Clicks, and then clicks are going to have partitions, partition 0, partition 2. And so clicks are partially ordered. It means that you don't know in which partition it's going to land, but as soon as it lands in a partition, it's totally ordered. Inside that partition, you store data in files, and we call this segments. We talked about it last time, so if you guys are new to stream, please go check it out. And so anyway, so now that you can store data in S3, let's say that you're trying to delete the data, and so you put an eviction policy locally, and there's multiple evictions. There is eviction for shadow indexing, as we call the main feature, and then for the regular Kafka API, right? So Kafka API eviction. And so what you're going to tell the partition is, after, I'm going to make this up, after 7 days, which is the default, I want you to go back and clear this data. The reason this is needed is that data in streaming is immutable, and it's a problem and an advantage. The reason it can become, what we call basically the engine of record, or streaming engine of record, is that immutability is a really powerful concept, in that once it lands in Redpanda, there is no API to mutate it full stop. You can't change it. It is what it is. It's an exact copy, and there's like 4 or 5 checksums in the hard drives and files that keep this thing in sync and correct, and is replicated and it's uploaded, etc. But it also means infinite retention. It means that if you care about this thing, it means that you have to keep it for a while. And so if you have to delete this data, the controller is the only, and so we have basically this control loop, which is different, not to be confused with the cluster controller. A control loop is really control theory loop. So this we have this loop, this correctness loop, let's call it that because it's simpler to understand. Understands which of those particular file handles that we talked about here, right? So is it S3 or is it the NVMe or is it the EBS, etc.? Which of those have been uploaded correctly to S3, and we've uploaded the metadata and the indexing, and basically we've done a two-phase commit on a bunch of files before. Let's see, we're in slide 7. Before we can delete the data. And so in addition to that, we can give correctness guarantees. It's not just uploading the data in terms of deduplication, it's also about data deletion. We will not delete the data. The node will crash, and Redpanda will crash if you experience a long enough outage against the tiered storage. And that's by design. People trust us with their mission critical data. And so I would rather, and we've made this choice explicitly, right? We are a Raft implementation. We save multiple copies on every write. It's the best of the quorum, as opposed to Kafka is the worst of the ISR chain. And so we care a great deal about data correctness, and in particular about data safety. And so
wait, so tell me about that part. You're saying the Redpanda broker will stop accepting writes if the blob storage is down too long. Is that what you're saying?
Yeah. Yeah.
That? Okay.
No, I think you got it. and that's by design. And so typically, right, people often have enough budget. They'll provision like a terabyte hard drive and whatever. And most of their workloads is a couple 100 gig active workloads. And the user does, it's not like we wait until the disk is full to start uploading. As soon as the segment fills up, we'll start uploading. So there's often a huge amount of time, like days, before like you actually run into this. But I think that's an explicit choice, because I would rather crash but give you a consistent mental model of what data is actually stored than just continue and be like, YOLO, baby. That just doesn't make any sense, exactly. Right? If you're trusting us with your mission critical data, like I can't show up with a straight face to a customer and be like, sometimes if like you have bad connectivity, like you'll just I don't know what happens to your data. That's I can't articulate the faults and how to reason about that. And so that was an explicit design decision. So we say we would rather crash than fail to make a tiered backup copy of your data. And the second highlight is the engine is the only thing that can actually make that kind of correctness guarantee. If you have an out-of-band process, the out-of-band process has no idea where the engine's index is in the tiered storage, right? Because it's out of band, and out of mind, out of sight kind of thing. And so that's a big part of the correctness guarantees of this. And we haven't really talked a great deal on the indexing layer and kind of the right path. But any questions from the audience or from you?
Not from me. Yeah, the big thing I was going to wonder. So you say, we're writing to these segments. After a gig or so, it gets it gets finished and sealed off. Do you upload it immediately to S3 at that point, even if then you keep that data around to serve reads for a while, or how do you sort of balance that?
Exactly.
When do you delete it? Yeah.
So we deleted based on the Kafka API policies, but they are you compose them, but they're orthogonal to a large extent. So the shadow indexing API is dependent on the Kafka API, but we block the Kafka API if it doesn't make any sense. Let me give you an example. So let's say Kafka says, I want you to evict data every second. Obviously, like I can't upload a 1 gigabyte segment to S3 every second from every single computer, like because of the sharding of the way S3 works, like you're gonna hit bucketing limitations. And we're actually done a kind of a ton of work. We should talk about the optimizations for randomizing the bucketing, so we actually get better cross-sectional bandwidth download. Before we get into that, and so let's say Kafka says something nonsensical, right? And the users that set this are just, they don't know, and so they're like, I don't know what this means. I'm going to set it to 0 because why not? And so so what happens is that because shadow indexing hasn't made a copy upstream, it'll say file system, this file is marked as non-uploaded. You can't touch it, and we'll lock the thing internally in the code base. And it'll try to delete, and it's like, oh, sorry, I can't do this. And it'll do the best it can locally. Once it's been uploaded, then it'll delete it locally. But we have to have those kinds of guarantees where shadow, the correctness of the data has to trump user errors. And no one, like, it's not, it's not like a developer goes out of their way to inject bad settings. Maybe an attacker would, but we're just trying to build in intelligence so that just common errors, like you forgot to add a 0, and now you're evicting it every second, as opposed to wherever you wanted to do it, or you forgot to, this is like the Terraform script goes bad, or an Ansible script goes back, and you forgot a day multiplier, and it just, it's like 0, like delete it as soon as you write it. It just wouldn't make any sense.
It won't let
and
you
so
do
that's why
silly, though.
Totally. So it's really more about helping the users correct against errors. So if we have so much to talk about, I think that there are basically big parts. Let me index them, and then we'll pick one. And I think we're just about to wrap up for that, and then we'll let people ask
I can't
questions.
believe how quickly it's fine by. So, like, what are some of the very interesting, the most interesting sort of optimizations you had to deal with in sort of building this feature?
Yeah, so big really shout out to the team for thinking deeply through this. I'm really just explaining most of their work. I've only been reviewing their PRs and design documents, but there's a multiple parts. So we have S3, and S3 had this. They claimed that they removed this prefix sharding, but it's not true. And so we've measured in practice, and in multiple regions. Or maybe it's our account is flagged, but then you ask all of your friends, and they all run into the same problem. So it's like, well, there's a disconnect somewhere. But the point is that they took, I think, the first 7 bytes of your path, or something simple like that. And then, internally inside S3, they have pools, or where these objects are going to, they call them buckets internally. Anyways, and so you put your files there, and it's really a flat namespace largely. And so imagine those are all like, backup files. So what we've done is there's a 2-stage index lookup where we locally randomize this. So this becomes a random ID prefix. So there's an integer 32, and then we hex encode the int 32, and this is a random thing. It's actually not quite as random. It's the hash. It's like a seeded hash, so that we can deterministically reproduce the same hash. But to S3, it's just like it's very random.
It looks random.
And what this allows us to do is that on the read side, it's, let's say that you have 5 Redpanda nodes. 1, 2, 3, 4, 5. If you were in the same bucket, this is limited, I think, to 1 gigabit per second download. And so all of your download in aggregate, right? So the sum of this would be 1 gigabit per second. But because we've randomized it, and so now we have multiple buckets. And so what happens is S3 is never the bottleneck. It's kind of the gist of it. And so you have some overlap now, and then and so now every bucket can give you that, or at least this is what we've measured to be true in practice. And so now you go from 1 gigabit per second to 3 gigabits per second, right? Because all of these are 1 gigabit per second. So this optimization moves the bottleneck into Redpanda where it should be, right? Like I shouldn't be bottlenecked by my upstream vendor. Like, we need to work around these things. And so it was really this gnarly whatever. It's almost like a triple index layer, because locally there's a 2-step function, because you can't map just a file to a particular path. You have to map a file to a bucket, and the bucket jumps into the particular file in S3. So it's a 2-step lookup locally, which is fine. It's like a couple of maps in, whatever, string to string map. It's actually an integer to string, but the point is, it's like, think of it like a name resolution service internally for this. And it's all sort of abstracted away by this handle idea. And so this was really useful in it's co-designing the read with the write, right? Like we need to co-design this, and a bunch of the bucket storage systems actually do this already. So if you ask friends that work at Google or friends that work at Azure, a lot of this info isn't public, and you just have to measure. And so here it is. So if you haven't done this, this used to be the case. Ask some friends from Netflix or somewhere like that, and they'll tell you all of the details, because they've run at a scale that you haven't run into. And
super
then I know
to hear that's still the case. Yeah, because I know they sort of were saying that some of that prefixing stuff had gone away. So interesting to see once you test, still there.
Totally, this was still the case last year when we tested. So I mean, take it for what it's worth. Do your own test, really, at the end of the day. This is what we measured, and so we have to design for the systems now. I can't go to a customer and be like, trust me, this vendor has got it covered. It's just, it doesn't make it right. Like, we are responsible for the transitive closure of our dependencies, ultimately, especially when we expose this as a cloud service. And then, another really interesting things is actually the control loop for uploading. And so okay, let's control loop. And so what this is that you have foreground work. And this is really the thing that people are going to benchmark against. This is the thing that that when you do a Redpanda, let's say, against Kafka or Porsa or NATS or whatever it is, a benchmark, you have your foreground workloads, right? And so you have a client, and it's called this foreground. You have this foreground workload, and so you're producing, and then you're consuming, and it's storing some data here. Let's say a three-way replication for simplicity. Now what happens is, as that data ages, I need to use some part of the IOPS and the network bandwidth. And so I have to steal a little bit of this bandwidth and a little bit of this bandwidth and a little bit of this bandwidth to upload it to an S3 object store, right? So GCS, Azure Blob Store, let's say to S3. And so I'm going to take a file and then upload it to S3. And so this control loop says, this is really one of the coolest things that we've done. What this control loop says is, like, measure and make sure that this, let me pick a different color. Make sure that this workload doesn't affect the main, say the black lines. That was one of the fundamental differences in our design. Why? When you have a burst in traffic, right? So first of all, let me be clear. If you're producing more than the usually network inside the data center is never going to be your bottleneck. At some point, there is no magic. Like, if you're saturating all of the devices, Redpanda will fill the disk and it'll crash, and like you need to do something, right? Most people never get there, right? Like, most people are savvy enough that they're like, oh, I'm producing a megabyte per second or a gigabyte per second, and they'll provision accordingly. So what we really want to adjust for is that sometimes you have spikes. And so the control loop, it's a steady state, and it would yield network resources, which is a very precious thing, to the foreground workloads, so that when you run a benchmark against Redpanda, or when you, really, it's not just a benchmark. When you're actually having a production workload, the worst thing that can happen is cause this cascading failures. And so if you back pressure the foreground workloads, it means that you're going to have this other, downstream systems. Maybe ClickHouse isn't getting updated, or whatever, or Mongo, or Single Store, or Materialize. There's a bunch of queries that depend on the foreground responsiveness of the produce and consume workload. And this is where the SLAs are. So if people have SLAs on their APIs, Alpaca is a company, right? So they produce a 1.5 millisecond P95 latency when they move to Redpanda. So because our customers' SLAs are based on the foreground workloads, I can't violate their SLAs by prioritizing the background. And what is cheap is I could tell them, you know what? add another 200 gigabyte disk and it'll be sent on this, and then you don't have to worry about that. That is a business decision that they can control. And so this is, I think, to me, one of the coolest optimizations that the team worked on, which is to make sure that it does what you expect it to do. And this is the technical thing that makes it do the right thing. And we haven't even talked about cross-core resource utilization.
I know it. I know it. There's so many interesting things. I think, oh man, unfortunately, our time has just flown by. So a couple things I want to do here is number one, I want to share a little bit about how to get some swag. You know, Alex is wearing some pretty cool swag. I do not have my swag yet, but it's coming tomorrow. I'm going to be wearing it. But if you're interested in getting some Redpanda swag, there are a couple ways you can do that. Number one, you can join the Redpanda Slack and DM Maria or Bob in there and get that. So join the Slack. You can go to redpanda.com and figure out how to join the Slack, and we'll make sure to get you hooked up with something there. So do that. I just want to summarize what we sort of talked about and make sure I'm understanding it at the right level. So again, we're talking about this tiered storage, and I think the interesting thing is, you know, how Redpanda is doing this versus how other people are doing this. If you're just using sort of, you know, the basic Kafka, right? Because people do want to have this historical data, but how are they doing it? They're using sort of a more naive process, you know, like you're saying, a shell script with a cron job that's just uploading everything they have on disk up to S3 or whatever blob storage you have. But now it's not, you know, now you have n replicas, or whatever your replication factor is. You're storing 3 times as much data as you were. Number two, you're also you have different APIs to access that data, right? So if you do need to go process everything that happened before, you can't use the Kafka API for that. You're gonna have to go use some batch process to get everything historical, and then sort of switch over to you know, the Kafka API at some point. And then third, exactly. this last one was super interesting, how you can actually manage those resources in a nice way, and make sure your backup process isn't interfering with your live process. And again, if you have that shell script, that backup.sh or whatever, that's just uploading stuff to S3, it doesn't know that there's a spike happening, and now you're messing with your producers or your consumers or things like that. So by, you know, all the benefits you get by integrating this into the controller in Redpanda, I think is helpful in a lot of different ways. Did I get that right?
Yeah, I think so too. And there's just, I guess I would give an umbrella categorization, which is people with an out-of-band protocol cannot give the correctness, performance, and guarantees and cluster stability guarantees that the engine itself can give, because no other software is going to understand the internal state. And we've also really kind of have gone out of our way to make sure that it is the case, and it behaves in the way that people expect it to. So yeah. So anyways, it's been a ton of fun. People tweet if you're interested in also getting a swag too. I don't know if you mentioned that.
I forgot to get Alex, that one, but I got that caption up there too. Yeah, tweet, you know, Redpanda data #RightPath. If you want to get some swag that way, we'll get you hooked up there.
Cool. Well, Alex, thanks for hosting. It's always a ton of fun to come to the show.
Likewise. Thanks, Alex, for sharing your knowledge with us. Everyone else, you know, we'll be back in a couple weeks with some more Redpanda internals. Thanks, everybody.
All right. Bye, guys.